All right, data moves for data science. I am currently associated with a high school. I also have been a freelance stats educator for some time. And I'm really interested in this idea that I'm calling, and my colleagues and I are calling, data moves. And these are the manipulations you might make to a data set in order to change its structure or values. And we'll see some examples of that. And I'm going to spend most of the talk using CODAP, which, judging from the names that I've seen in the participants, which I don't recognize, which is very exciting, I'm thinking that many of you may not ever have seen CODAP, and so I think it might be interesting for you to do that. So in the page here, we see we have 5 phases. We'll see how many of them we get to. These are like snapshots of the document I will be doing. If you want to play along, you can play along and follow along with what I'm doing, or you can just watch. And I will be using CODAP and talking, commenting on what I'm doing. So I'm going to go to phase 1 here. And in phase 1, what we have is a plug-in, a data portal over here on the left-hand side. And what we're going to be doing is downloading data from NOAA, the National Oceanic and Atmospheric Administration. And if you are a climate change believer like me and a stats person, you recognize that weather is not climate. And if we say, oh, could we actually detect climate change in weather data? It's not obvious that we're going to be able to do that. And so we're going to pretend to be not exactly high school students, but high school teachers thinking about a high school level in terms of getting data and seeing what we can find. So in this, you can see there are instructions if you want to follow. I'm just going to press get data and see what we get, because one of the first things we want to do is see what the data look like. So I press get data, I retrieve 24 observations. Why did I get those observations? Oh, if I look here under stations, I could see that I'm getting data from State College, Pennsylvania and Fairbanks, Alaska. And the data that I'm getting is average temperature. So here are data in a table. And one of the first things we want students to do is make a graph. And in CODAP, I just click graph and I get a graph. And that's a funny looking graph, isn't it? Because it's got just dots all mixed up. That's all right. It's still the data. In order to organize my graph, I do what I tell all students to do, which is label your axes. So I'm going to put when, I'm going to make this a little bigger so you can see, I'm going to put when, excuse me, on the horizontal axis. So I drag it to the horizontal axis and drop it. And there are my data. And I see, oh, it looks like it's most of 2019. Oh, I can see over here, it's from January 1st, 2019 to December 31st, 2019. Oh, it's all of last year. And I'm going to put the value on the vertical axis. And we've learned before, it's the average temperature. I'm not going to look at anything else. And that's what the data look like. And I see these two look like patterns. Oh, I've got 2 different places. I wish I knew which one was which. I bet you know which one is Fairbanks and which one is State College. If I click on one of them, it will be selected in the table. And so that one is from State College. And if I click this one, it's from Fairbanks. I'd really like to know all of them. So I take where and I drop it, plop it in the middle of the graph. And that creates a legend so that I can see, oh, there's the data for Fairbanks and the data for State College. Not surprisingly, it's generally colder in Fairbanks than in State College, Pennsylvania. And that's, we've now gotten to the end of phase 1. And because I've succeeded at getting here by 5 minutes after the hour, I'm going to point out that what should we be looking for? Why do I have Fairbanks there? And that's because we've all heard stuff about global warming. We might have seen graphics like this one. So this is a graphic from NASA that shows, in this case, overall temperature change, where red is getting warmer and blue is getting cooler from 2012 to 2016. And we've probably heard that, oh, it's the Arctic regions that are changing more. Oh, but look in the Amazon and look in the middle of Australia. These Arctic regions are maybe changing more than some other places. And so that's why I picked Fairbanks as one of my stations. So I'll close this. And I'm now going to go on to phase 2. So I'm just going to click on my phase 2 document. And this is sort of where we were. And looking at this data, I might be interested, how would I manipulate the data in order to compute average temperatures? Well, we know what we would do, and maybe it's the right thing to do, and it's what we are going to do, is add up all these numbers and divide, but we don't want to just add up all the numbers, we want to separate them so that we add up the state college numbers differently from the Fairbanks numbers. And so I'm going to perform this important data move. I'm going to make groups out of the table. And the way you can do it in CODAP, and this is now intermediate to advanced CODAP, so we trust you to sort of go with it. I'm going to take this where, and whereas if I'm making a graph, I would drag it, I'm going to drag it leftward in the table into this white space that turns yellow and drop it. And what I have done is separate the data into 2 smaller data sets, a set of hierarchical data sets. There's the data that's just State College. Notice I clicked and everything selected, including the graph, or just Fairbanks, and I click on Fairbanks and it scrolls to the beginning. That is, the right-hand side of the table has reorganized itself so that all the Fairbanks data is together and all the State College data was together instead of interleaved the way it was before. And at this point, I can now try to compute my mean. And I'm going to go, there's a gray circle with a plus sign in it. I click there. I'm going to call it mean, capital T, for mean temperature. That's the name of the variable, the attribute. It has nothing in it at the moment. So I'm going to get my menu here. I just clicked there. I click edit formula. And I'm going to say, this is the mean of, and the value I want to take the mean of is value. So this is the, whoops, I need to spell it correctly. Value, and I get a little bit of type ahead to help me. And I'll click apply. And now I see the 2 mean values. And these are in degrees Celsius. So State College has an average temperature of about 50 degrees Fahrenheit. And Fairbanks, you can tell, averages right around 0 over the course of the year. Okay, so now we've just reached the end of phase 2. It says enter mean value and press apply. And I want to see if I can move this thing. So it's, you guys who have presented in Zoom know that it was over my tabs. And I just want to ask, Carrie, can you still see my screen?
Yes, you're good.
Okay, great. So I'm going to move on to phase 3. And it should look kind of like this when I change. Looks very much like this. That's good. Okay, so we've computed means for 2019. And I'm interested now in getting additional data and seeing what happens. Remember these numbers just briefly, 10.31 and 0.33. I'm going to get the rest of the decade. So I'm going to change these numbers over here, and I'm going to say 2010 to 2018. So this will get me everything from the beginning of 2010 to the end of 2019, and I still have the same stations and everything like that. So I press get data, and let's imagine, what do you think we will see? Request was sent. We hope that NOAA is awake. NOAA is not awake. We're in trouble. You can do it. It still says request sent. Well, we do have alternatives. My internet connection is unstable. Oh, here we go, 216 observations. And that's kind of what we might have expected to see. Although these numbers changed. Oh, because we have now the mean of 10 years of data instead of just the mean of 1 year of data. Okay, I wonder what happens. Could we just get the mean of every year? Here's how we can do that. And this is sort of an oh my God experience. It was the first time I tried it. I'm going to take year and I'm going to move it left to put it next to where State College and Fairbanks are. And what's going to happen is I drag it to the left, and you can see I'm going to just plop it in here. And I'm going to get every combination of year and where. That is to say, a Cartesian product of these two things. But not only that, if I look, for example, at this case over here, this is State College in 2010, every single group of the now 20 groups that I have is put together. So this is all just, the selected ones are just State College 2010, and I get the mean of State College in 2010. That's really interesting. Furthermore, these columns over here are first class data. So I'm gonna make this smaller and make a new graph, and I'm gonna put year on the horizontal axis, and I'm going to put where on the vertical axis. No, I'm not going to put where on the vertical. I'm going to put where on the middle, and I'm going to put the mean and temperature on the vertical axis. And now we have a graph taken from the individual monthly data of the mean temperature by year by place. And I claim this is actually a very sophisticated and kind of difficult thing, that sometimes students will be confused when you group by, and I say group by intentionally because if you teach with the tidyverse in R, you will recognize these data moves that I'm making with drag and drop as being conceptually the same as the most important verbs in the tidyverse. So this is group by, and we've also done summarize. But there's always this question of what do you group by? So I'm gonna go right on to phase 4 without changing anything so that you can see this. Actually, no, I'll just go to phase 4 here. Here's the graph we just made, and I'm gonna put where in the middle so that you can see it, Fairbanks. And what I'm gonna do right now, I'm gonna drag year back to the right. So we are no longer grouping by year. And so that we don't see anything. And I'm going to put month on the left. And if I put month on the left, I now have grouped everything by month. So if I put month on the horizontal axis, this graph shows the mean of all 10 years by month. So this is all 10 Marches in Fairbanks. If I click here, I'm going to see March in Fairbanks. Whereas if I go back here to phase 3, this is the entire year, January through December for 2016. So we've done group by in 2 different ways, simply by dragging back and forth and seeing the consequences. And because it's easy to change, to drag back and forth, it's easy to make mistakes and fix them and see what goes on. So we've now colored the points by city. We've done this thing, that's phase 4. I'm gonna move on to phase 5 because it's already 1/4 after the hour and we wanna do this next part. Phase 5, this is gonna be like in a cooking show where they're making a turkey and you just put the turkey in the oven and then you come back from the commercial and they're taking the turkey out of the oven. I'm gonna skip a few steps. And so here we are in phase 5. What we've done is, you can imagine what we did. I went from 1930 to 1939 and grabbed all that data because I recognized back here in phase 3 that I can't really see temperature change very easily. It's only 10 years. But if I could get data from the 30s, maybe I could see something more dramatic. And so this is where we've got this thing from 1930 to 1939, and we have 2010 to 2019, so I have kind of a bigger baseline. Furthermore, I made another attribute, and it's not difficult to make this, but for time, I made it for you, which I've called era. And I've got 2 eras, ancient and modern. And ancient is before 1950 and modern is after 1950, just so you know how it's defined. This graph now shows the graph by month, but it's averaging everything from the 30s and the 2010s. So I want to do what it says here. I'm going to drag month back to the right. I want to find the average temperature for the 30s and the average temperature for the teens. And so to do that, I'm going to use era as my grouping variable. So instead of month, I go back, I put month back over here, And here I can see for every month, the mean is the same because the mean is the mean for the entire place. And I'm going to put era over here so that I separate it by era. So I have every combination of State College and Fairbanks and modern and ancient. And I'm going to put era on the horizontal axis. And even though it's categorical, it will make a graph for me. And I can see, oh, going from ancient to modern, in both cases, you can't see in State College so much. But as we saw in that colored graphic earlier, I can change it. In Fairbanks, the difference is actually much more dramatic. In this case, I can't tell exactly, but it looks like about -4 and -1.5. So it's like 2.5 degrees Celsius average between Fairbanks and, ancient and modern in Fairbanks. I'm going to put month left again. I'm going to take month and I'm going to drag it to the left in order to see what we can see if we look at things by month. I'm going to put month on the axis one more time. And now I see those. And I would love to know which one is which. So instead of Fairbanks and State College, I know which one is Fairbanks and which is State College. I'm going to put era in the middle of this graph. Now, modern is the orange dots and ancient is the purple dots. And so a question that students can ask themselves is sort of, is it in general true that the orange ones are on top of the purple ones, above the purple ones, or below the purple ones? And I can see here in State College in the 30s, which is ancient, was warmer than State College in the teens. But most other places, the teens are warmer than back in the 30s. Modern is warmer than ancient. And so since we have a few minutes still, I want to say, well, let's not skip ahead in this case, and I'm going to compute the difference. So in order to compute the difference, I'm going to sort of try to imagine, what do I want to see? The thing I want to see is for every month, I want to see the difference between ancient and modern for both State College and Fairbanks. And to do that, this is an example of the kind of thing that gets really confusing, even for us when we're doing programming, of trying to decide, wait a minute, how do I group it? If I'm using a programming language with looping, where's the loop? What loop is inside what other loop? And so I'm trying to think of, well, what do I want to have constant? And the thing I want to not change is I want the place to be a constant thing. And I want the month really to be a constant thing. And I'm going to drag that to the left also, so I get every combination of place and month. Those are the things I want dots for. And by the way, notice that I now have a 3-level hierarchy in this table. And so if I look at January in State College, I have all of this data, but in the middle, I have both modern and ancient, and these are the two values I want to find the difference between. So I'm going to create another new attribute up here, and I'm going to call it diff. And I'm going to give it you kind of have to know CODAP formula in order to see that this is possible, but you know what's going on. I'm going to say first of mean t minus last of mean t. We would love to be able to just address them like you would with a real programming language. Can't do that yet. We're working on it. And I click apply, and these are all the differences. And so now instead of, actually, let's just go ahead and we'll make a new graph because we can make as many graphs as we want, and it's easy to make the graphs. What do I want on my horizontal axis? I want month. Vertical axis, I want diff. And for a legend, I'm going to put where so I know which one is which. And sure enough, this graph is one that I think actually tells a story that's pretty interesting. For most months, comparing the teens to the 30s, the difference is positive. That is, it's warmer in the teens, and it was warmer now than it was in the 30s. This is the real exception, and that's the situation we saw over here. Notice I clicked this one, and both of those are selected because those are the 2 items for that month. So this is State College in January. But the difference for Fairbanks is much bigger than the not so big difference in State College. Is this solid evidence for climate change? Of course it isn't, but it's an opportunity for students to mess around with the data and find the kinds of quantities they might want to compute and work with in order to do further study. If it's at the high school level, I accept this with enthusiasm because the students are messing around with the data. They are using what really is computational thinking, melding that with their understanding of data, which is where we get data science after all, and making a display that they can explain that communicates something of interest to their reader. So I'm enthusiastic about that. And I also want to mention another thing before we just open up for questions is, let's look at this just for a moment, this graph. A naive statistics student might say, well, how are we going to tell the difference between the 30s and the teens? I know, let's do a t-test of means and see whether the means between these 2 things are significantly different. And it is not unreasonable, or it is unreasonable, but it's not uncommon for even a successful student in introductory statistics to make this blunder. Because these 2 things aren't, the variability in these 2 things is not due to randomness. A bunch of it is due to, for example, what month it is. So if I just choose all of the Januaries in Fairbanks, this is the sort of thing that maybe I would want to test. Or this difference, the Februaries, where I see a 4-degree difference Celsius, 4.5 degrees Celsius difference in means, as opposed to looking at this whole thing. And so I think there's a problem that we have when we start to work with rich data where the data have not been pre-digested by us statistics teachers in order to make a particular point. We turn students loose on a project, and often they make blunders that it's perfectly reasonable that they should make. Instead, I think it would be really great if we spend a little more time thinking about what are these data moves? How do I find the data that are really relevant? Okay, that's enough out of me. We have a few minutes for questions.
All right, great. Well, thanks, Tim. This has been a fabulous presentation so far. And we do have quite a few questions. So the first one asks, is there a database or website that houses more of these CODAP data sets already set up? Even better, do you have other activities to go along with them?
Okay, what a great question. I'm going to go back to I'll show you pointers to some resources, and maybe I will add others. So CODAP is made by the Concord Consortium, which is concord.org. I didn't put their URL here, but if you go on the web and search for Concord stuff, they have a whole page, and I will put on this page, as soon as we finish, a link to a whole page of data science-oriented things. But down here under links and resources, there's a whole bunch of things. There's other weather portals, a blank CODAP document. Projects that I'm working on are at this URL called CODAP.xyz, which is something that I run. And one of those projects is an introductory set of lessons about CODAP and data science. And it has pointers to a number of other things, and so does CODAP.xyz. So Awash in Data is an introductory book, which ironically is written in R Markdown. So anyway, that's something, but if you go to codap.concord.org, I will just write this in here, codap.concord.org, and that way you will find a number of other resources with data sets and things like that. I'm particularly interested in making these plugins, for example, data portals to give access to more data from different places, of which one of my favorites is BART data from here in the San Francisco Bay Area. We have 40 million cases of transit data, and it's astounding. Okay, another question.
Great, thank you. Tim, it's very clever how easily you can slice and dice. How do you make sure that students think through what they should do to answer a question and don't just rush into doing everything chaotically?
Oh, what a great question. The thing that we're worried about is the same as menu shopping. When kids see a menu of all the different statistical tests they can do, and you choose one and you choose another, and you keep going until you see p is less than 0.05 or something horrible like that. So on the one hand, you can't be sure. And I'm also eager that students slice and dice the wrong way so that they see what it looks like. But the question is, will they recognize that it's the wrong thing and undo it and make it right again? So to that end, one of the things that I do is, I just did a 4 or 5 session introduction to data science at the high school level. So this is all the time they had, but we actually had them turn in 3 assignments in that course of that. And they're very short, but by looking at the first assignment, in which they are slicing just one kind of little way, we can then come back and describe to the class all the different wrong ways to do it, using examples actually from the class. And it's low stakes. We see, and we really want to focus on communication. What are you actually communicating? We then can also give them strategies for telling if they sliced it the way they thought, which are things like, oh, so like you saw me do some of those. Select a point and see whether all the data in the table is the data you think are the ones that are getting averaged, for example. And so there are various things to do, but giving them feedback, having more than one product so that they can screw up on 1 or 2 products and then do better on the later ones. Another thing I've been trying, and it has been, as usual, successful with the most well-prepared students, and we got to figure out how to make it successful with everybody, is asking them to explicitly tell me what data move they're using. And we give them specific moves. So if it's, oh, this is a grouping move, this is a summarizing move, this is a filtering move. And frequently students can actually do that. And I believe, without evidence, but I have a conjecture that by doing this sort of metacognition, they can actually improve what their choices when they do things. Okay, next.
Great. So the document says that traditional stats tools are coming, but not yet present. It says May 2020. Is this available? If so, where? If not, when?
Okay. I do not actually work for Concord Consortium. I'm a freelancer, so I have no control over these things. I don't know if Holly Lynn is in the audience. I think that she has a project that part of it is trying to make some more traditional stats tools available in CODAP, as they were available in Fathom, which is CODAP's sort of grandmother. It depends on who has a project that has money to pay the programmers in order to make this happen. I'm an unpaid programmer, and so if I am, it's not unlikely that I will create something that will help me do the thing that I want to do, which is where this NOAA weather plugin came from. I wanted to use it with some students, and so that's why it exists. And so I'd be really interested, especially in using the sampler, which now exists, in order to do resampling and scrambling for that kind of inference, as opposed to just making t-tests and stuff like that at first. I think we need both, and I'm sorry that I don't know any better about when they will arise. It's always later than I want.
All right, well, thank you very much. There are a few other questions, but it's 11:30, so maybe if you just want to type the answer after the session, they can get their answers that way.